Hey, sorry I can't be here with you today, but I want to go over a few things with you. If you are in the technology station today, you are going to first finish up the operation of integer practice. Hit that blue button to turn it in. Then it is the knowledge check for Alex. And after you have finished those two, or you don't have a knowledge check, and then it is a minimum of 10 topics learned for Alex. Now, when you're doing the topics learned, you can use calculators, and I do have some on my wall, and they are assigned to you, and there's a clipboard for you to use. It's the same as your computer number, but make sure you put my calculators back the way you found them, because if not, if we find calculators like this, you will no longer be allowed to use my calculators, and that will make math class very, very hard. And if you are caught destroying my calculators, I will be happy to take a picture and send that to your parents and let them know what you have done to property that is not yours. So please be mindful and take care of those. Thank you. Now today we're going to start 1-2 multiplying monomials, day 1, if you are with me. And then in Miss Sunny's group, if you didn't by chance finish that 1-1 assignment, make sure you get that done. There is an integer chip assignment activity for you to do. And then once those two are done, if you want to play the game, the multiplication war, that is with her. So if you are with me, continue watching and we will get started with our notes. So a monomial. A monomial is simply a number a variable or a product of a number and one or more variables. Examples of monomials: 4, x, 6, y, 7, x, y. The list goes on. That is just 4 examples of what a monomial is. Today we are going to learn to multiply powers. We've actually did this with 1-1, so this should look familiar. We have 2 bases for this problem B. We don't want twin bases, we want one base. So we keep 1b and we add our exponents, which is what they did here. So it went from b to the -4th power times b squared to b to the -4th plus 2nd power. So we are going to simplify that. B and -4 plus 2 is -2. And if you remember from lesson 1, when we see a negative exponent, we want to think fraction. So we're going to go 1 over b squared as our final answer for that. Now, just like on our last session, sometimes we have more than one type of base. Here in this problem, you see we have twin bases of m and twin bases of n. So we are going to combine what we call like terms. Like terms have the same base. Okay. Like terms have the same base. So we're going to take our twin m's and we'll combine them into 1m. And then it's 3 plus our -9 times our other base. We have those twin bases of n. That becomes one base. And then we will add our exponents, -2 plus 5. Now we will continue mathing, and we'll bring it down one more time. Well, 3 plus a negative 9. Well, this is something we call a kissing sign. I call them kissing signs because they are right next to each other, as if they were kissing. So if you have a positive right next to a positive, well, it's a positive times a positive, and that is a positive. If you have a negative next to a negative sign, a negative times a negative is also a positive. But when you have a negative kissing a positive, that is a negative. So here we have 3 plus a negative 9. So we have a positive and a negative kissing each other, so that is a negative. So it's 3 minus 9, and that would be minus 6. Times n minus 2 plus 5. Well, that is plus 3. Now we have this m, and it has a negative exponent, and we learned last week that if we see a negative exponent, we have to think fraction. So, but currently it's multiplied by n cubed. So what we do with this is now n cubed becomes the top of our fraction, or our numerator. And this m to the negative 6th power that did not want to be a whole number becomes the bottom of our fraction, and it loses its negativity. So what I want you to remember in your summary is that when you multiply powers, and that's what we were doing here, we are going to keep one of the twin bases, and we are going to add our exponents, keeping in mind our kissing sign rules. Okay? Now, once you're done with the summary, everyone flip it over. We're going to pause the video, make sure you have the entire sheet done, and then flip it over, and that will signify for them to unpause the video and to go on. Now on the back, this is something new. We are going to do the opposite because we are dividing instead of multiplying. I told you last week we do the opposite a lot in math. Well, you also may notice that in the parentheses, we have an m divided by n. We're going to treat this as one base as we go through this problem. So we have m over n cubed, and that whole thing is over m over n to the negative 5th power. Again, treat this m over n in parentheses as one base. So we are still going to combine that one base. Okay, m over n, and it is in parentheses. It's twins, we combine it because we only want one. Now with our quotient power rule, because we are dividing, we are going to subtract our exponents top down. So it was 3 minus a negative 5. You always subtract top down. Now look, remember your kissing signs. Okay? Remember those from the front. So a positive and a positive equals a positive. A negative and a negative is a positive, while a positive and a negative is a negative. We have a negative kissing a negative, so that means it's plus. So it's really what we're talking about is 3 plus 5. So then 3 plus 5 is 8, so we're going to keep our base. And our exponent is 8. 3 plus 5 is 8. And ask us, so this original problem simplifies to m divided by n to the 8th power. Now, what if we have more than one base, like example 2b? Okay. We are going to math our like bases separately, just like we did before. So we're going to take these one step at a time, just like we did to that one problem we did last week. So we have q to the negative 3rd power over q to the 5th power. Remember, we only get to keep one of these bases. So we're going to have q. And we subtract our exponents top down. So q's exponents minus 3 minus 5. And don't forget we're multiplying by our next base. Well, our next base is r. And r is r to the 7th over r to the negative 1st power. So you subtract these bases top down. 7 minus a negative 1. So we're going to math our exponents. We have q is our base. Minus 3 minus 5 more is minus 8. We're multiplying by r. 7 minus a negative 1. We have those kissing signs again. So this is actually, we're going to think that's a plus sign, because it's minus times minus is a positive, so 7 plus 1 is 8. And when you look at this, we're like, well, we have a negative exponent. And negative exponent, we think fraction. So this is still not our final answer. R to the 8th power wants to be a whole number, so we're going to put that on top. Q to the negative 8th power did not want to be a whole number. It wants to be the bottom of a fraction. And once we make it that bottom, that denominator, we lose the negative and we keep our exponent. So our summary for when we divide powers, this is actually the only thing new today. So when we divide powers, okay, we're simply doing the opposite of what we did with multiplication. We are going to still keep our one base. When you have like bases, when you have twin bases, you only get to keep one. But then you're going to subtract those exponents. You're going to subtract the exponents top down. Okay, and then remember, you end up with a negative exponent, you have to think fraction. So now I want you to take your notes. Remember, your assignment will say example 1, example 2. So decide whether you're following the front or the back. And then also don't forget, if you don't finish it in my station, it's no big deal. You will have time in this sunny station.